had left off, last time we were talking about solving these trigonometric equations, and I'd asked you to work on 15 to like, I don't know, like 45 or 46 or something terrible. Are there questions from any of that we want to talk about, or even earlier assignment, I suppose? Josie.
Two things. On the board, it says 15 through 30, so
that's going to be what's due, because it felt like 15 to 46 by Sunday was going to kind of ruin everybody's weekend.
It was a lot. You're so nice. It's
so
still
like,
a lot. I think we should do like the odds or the
we are going to do all of those problems, but like for this Sunday, we'll just worry about to 30.
Thank you.
I know that I know between sports and drama, it's a terrible week for some of us, so give you a chance after the week off if you need to kind of catch up to get ahead for when we come back. Elizabeth.
Is it this Sunday or next Sunday?
It's going to be this Sunday. They told us that we can't have anything due during break, so we're just going to have the homework set due at the normal time. But I shortened it because of that, right? If it was due next Sunday, I would have just left it at 46 and just been like, just don't do it all in one day.
Are you gonna look at it though?
It's just
Yeah, I mean, I probably won't get to it till Monday or Tuesday, but again, like for those of you that have turned anything in late, have I ever marked anybody down for turning in something late? Have I ever needed an excuse for why you need to turn something in late? No. So like, do the best you can with it. If you need another day, it's not the end of the world. Like, just email me when you finish, and I will eventually go back and update it. Probably not the same day, but we'll get it done. Josie.
Now can you do number 15?
I'd be happy to do that. You're welcome. All right, let's see. Okay. And you want to do like all the parts, I take it, right? Okay, no problem. So nothing to do in terms of solving, right? We're already at just take the inverse to both sides. And I go to the unit circle and I look up where y is root 3 over 2. That happens at pi over 3 and 5 pi over 3. No. Yes? No. Pi over 3, yes. Not 5 pi, or not 2 pi over 3, though.
No,
At
2 pi over 3, not 5 pi over 3.
Yeah, not, oh, it is 2 pi over 3? Oh, okay, good. Okay. I'm just doing the unit circle in my head, and sometimes I have it. I do have it mostly memorized. Sometimes you just like, you get confused. That's a 2 pi over 3? Okay, so that's part A. Good with that, Josie? Okay. Part B, all I'm going to do is tack on the 2 pi k piece to each of those. Good with that? Okay. Part C, I know that I have pi over 3, right? If I add 2 pi to that, it's certainly going to be bigger than 2 pi, right? So I'm just going to worry about subtracting a 2 pi from that. So that's negative 5 pi over 3. If I subtract 2 pi again, it's certainly too small. Is that, we're good with y?
And too small because of what's...
Yeah, the interval is negative 2 pi to positive 2 pi.
Okay.
Right? So just, if I subtract 2 pi twice, it's definitely too small. You know what I mean? Same idea here. So 2 pi over 3. If I add 2 pi again, definitely too big. So if I subtract 2 pi, that's what? It's going to be negative 4 pi over 3. And if I subtract 2 pi again, definitely too small. So that's that. And then d is negative pi to 4 pi. Okay. So I'm going to just look at the previous answers. So pi over 3 definitely lies in there. 5 pi over 3 is too small now, right? That's less than negative pi, so I won't take that one. 2 pi over 3 is good. Negative 4 pi over 3 is too small. Don't worry about that one. So all I need to do then is worry about things from 2 pi to 4 pi. So if I add 2 pi to this, I get 7 pi over 3. That's good. If I add 2 pi again, though, that's going to be too big. And then same thing here. I add 2 pi. I get 8 pi over 3. If I add 2 pi again, too big. So again, like the nice part, even though there is like parts A, B, C, D, they're all kind of built off one another where I can use my answers to the previous part to just get the next set of answers, which is nice. A little bit. Taylor.
So for like 23,
Yeah.
you have like plus or minus pi over 3 and then plus or minus 2 pi over 3.
Okay.
How did you get that?
For 23, you say?
Yeah. Like I know how you got the pi over 3 and the 2 pi over 3 because that's just from the unit circle. But why does it become plus or minus? Because if you subtract like 2 pi from that, does it equal negative pi over 3?
Okay. So for 23, you say part A is what is it? It's
Pi over 3 and 2 pi over 3.
no, that's not right. I understand that could very well be the case, but like that's definitely not the right answer because cosine isn't positive in the second quadrant.
Yeah.
Right, so that's just an error on the answer key. So let's note that.
And I don't think it's pi over 3. I feel like
Yeah, it's pi over 6, and then 11 pi over 6 should be the two answers. We definitely just thought, those would be the answers if it was sine and not cosine. So that's probably what happened when we're writing the key, is that somebody just misread it and started doing it as if it was sine rather than cosine or something. Or looked at the wrong coordinate or something, looked at the x or y coordinates instead of the x's. But that's what's going on there. This should be pi over 6 and then 11 pi over 6 for part A. And then you can go from there.
Or is it plus or minus?
I don't know.
Like that for like 19 it says plus or minus pi over 4. And plus
Okay,
or
so 19 it's going to be because it was cosine squared. Right, so that's the issue there. Do you want to do 19 through and just see where the plus or minuses are coming from?
Because it happened with 16, which is just plain cosine, as well as 15 on the answer key. That's what it says for C as well.
For C. Huh. Let's look here. So 15, part C. Yeah, huh. Did somebody just goof that? I think we did. Okay. Yeah, so that's definitely not right based on what we did.
Okay.
So again, my sincerest apologies. We'll see if I have enough time here over break to take a pass through this and really kind of double check these answer keys and do some updating.
Okay.
So, but anytime you see something that you're not sure if it's right or not, like
Yeah.
let us know and we can make some notes on the OneNote to at least
Yeah.
give everybody else a heads up that like, hey, that answer is not listed there is not right. I might not have the answer to put in there, the correct answer to put in there yet, but we can at least let you know that it's not, that you're not crazy if you're like, I did this 3 times, I couldn't get it to come out to
Yeah.
this.
Well, because that's what I did it, and then I went to go check it to make sure I did everything right.
Yeah.
And then it just was like completely.
And of all the problems to have the wrong answer for, the first one in the set is a bad one to have the wrong
it happens
answer.
on all of them.
It happened on all of them.
Not in 17. In 19 it's there, but you said that one was because it was squared.
I think 19, those are actually correct.
Okay, and then it happened in.
Should we do 19 and just double check?
Yeah.
Why don't we do it, right? Okay. So square root both sides. Cosine x equals plus or minus root 2 over 2. Is it okay how I got to root 2 over 2?
Yeah.
Okay. Break this into 2 equations. One with the positive root 2 over 2, one with the negative root 2 over 2. We'll do our inverses. Go to the unit circle. This is pi over 4 and 7 pi over 4. This one is 3 pi over 4 and 5 pi over 4. So that's my answer for A. Notice here that these answers are half a pi apart, right? These answers are half a pi apart. These answers are half a pi apart. So I can actually condense all of this together into one infinite solution. You could list it as 4 separate ones. I would mark it wrong, but that's probably the way it appeared on the answer key.
On the answer key.
This is 19. Yeah. Oh, it said plus pi. That should be a pi over 2, huh? Shoot. Errors all over the place.
Answer key is very wrong.
Yeah.
So I think it should just not be homework. Just not every time I check it, I'm thinking I'm wrong, and then we're gonna have a homework quiz on it, and I'm gonna be like, no way.
The homework quiz isn't going to be on section 5.2.
Well, it might be eventually,
That might be eventually. Fair enough.
or on the test, and
Um,
I'm gonna be like, oh, well, the answer key said this, and then the answer key was wrong.
okay. So for part C, obviously we have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4, right? If I subtract 2 pi from pi over 4, I end up with negative 7 pi over 4. If I subtract 2 pi from 3 pi over 4, that's negative 5 pi over 4. If I do the same thing from 5 pi over 4, that's going to be negative 3 pi over 4, and then negative pi over 4 when I subtract 2 pi from 7 pi over 4.
That was wrong.
So there's the plus or minuses. Those are correct. And then part D, where we go from negative pi over 4 to 4 pi, we wouldn't take those two, but everything else would come down because everything else is in the interval, right? Everybody's okay there? So you take the green stuff from C, and then after 7 pi over 4, we'd have 9 pi over 4, 11 pi over 4, 13 pi over 4, 15 pi over 4, and then 17 pi over 4 is too big because it's bigger than 4 pi. So those would be the 4 additional answers, other than the stuff from C, other than the 2 places that I X'd out, because they're too small. So I think that one might actually all be correct, other than the stupid plus pi k instead of pi over 2k on the answer key. Maybe none of the answer keys right. That would be really depressing for me. 17 you said was right, though, I think.
I don't know.
No.
I gave up.
You gave up.
When I got it wrong, and I was like, "Why did you do this all
That's
wrong?"
fair. That's totally fair. I understand. I would be unbelievably frustrated if I were in your shoes, too. I'm frustrated just looking at it going, ugh, how much updating do I have to do on this?
A lot, which is,
Do I have to just redo the whole thing? Maybe I kind of do.
I think 1 through 14 is right, because I did it with my tutor.
Yes, I feel like those parts were right.
No, it was just all these ones.
Yeah, the solving in here, it's like a lot of it's right, and then parts will be wrong, and that's frustrating.
Yeah, it's okay. We all make mistakes.
Yeah, it's frustrating. I don't know. I can't even remember who wrote these. I suspect maybe I did, though, which is,
I think your name is on
yeah, thanks.
Well, sometimes it says Chun on it, so.
Oh, no, between Mr. Stan, Mr. Chun, and I, we all wrote parts of these things and created some of these documents. And sometimes I remember to update the names on things, and sometimes I don't. So, but the book and the answer keys and everything, at one point, one of us wrote these things and did this.
Maybe
But this one, I seem to think it was probably my fault.
we can blame someone else.
No, it's I'll take the blame. It's fine.
If you want. It's no worries.
I can deal with it. I'm a big boy. I got my big boy pants on today. Grace.
So it's not like a question about this, but
Okay.
midterm.
Mhm.
Oh, that's
So whatever.
Let's talk about the midterm after Thanksgiving break, after I've had a chance to kind of think about how I want to format this.
Okay.
I'll tell you in the past, what we did last year was I just took exact test questions. So 2 to 3 questions from every test, and that was your midterm or your final. Maybe we didn't have midterms last year because of
Right.
COVID stuff, but that's what I did for the final last year.
Didn't we have you could pick each chapter and do 2 questions, but there was 3 questions there.
Yeah, maybe that, and they were all exact homework or exact questions from previous tests or something.
Yeah.
That sounds about right. I'd probably be landing somewhere in that same neck of the woods, but we can cross that bridge maybe after Thanksgiving, after I've had a chance to think about it a little bit more. But I get that you guys are thinking about it already. Alyssa?
Right, so just a little backtrack.
Yeah, totally fine.
Let's go back to 1 through 14.
Sure.
Number 2 and number 1, I guess. Can you just explain how you set it up? How you get
Mhm.
going?
Sure. So let's just do that. Okay. So did it matter which one we looked at?
No, but let's do 2.
Okay, fair enough, because there's no answer to that, right?
Correct.
Okay. So when I see a problem like this and I'm told that something is positive or negative like that, what I'm going to be using that positive and negative for is after I do one of the Pythagoreans and I have to square root both sides, deciding whether the thing should be positive or negative.
Okay.
So that's how I'm going to use this. So I know I'm going to be using a Pythagorean at some point.
Okay.
So what I'm going to do is I'm going to go to my identity list and look for a Pythagorean that has the cosecant in it. So that's P2, where it says 1 plus cotangent squared, in this case I guess we're using alphas, is equal to cosecant squared. Okay with that?
Yep.
So negative 3 squared is 9. Subtract 1 squared from both sides gives me 8. Square root both sides gives me that cotangent alpha is 2 root 2. And I drop the plus or minus because I know cotangent is positive in the directions. Is that all right?
What's the answer? 2 square root 8?
Oh, 2 root 2, excuse me. Yeah, my apologies. It was square root 8 or 2 root 2. So far, so good.
Yep.
Okay. So then what I'm going to do is it's actually asking me for secant. So I'm going to go and say, okay, is there an identity that relates secant with cosecant and cotangent? So if I go look at my identities, I know that cotangent, we're using alphas here, is equal to cosecant over secant.
Which one is that?
That's Q2.
Okay.
So I'm just going to rearrange that to get the secant by itself. So I'll multiply both sides by secant and then divide by cotangent. And then I'll just fill in the values for those two. And when I rationalize my denominator, I get negative 3 root 2 over 4. So does that kind
That makes
of...
a lot more sense.
Okay. Yeah, so typically, again, we're going to start with a Pythagorean, and then almost always you end up using one of the quotient identities
Okay.
because it's the only thing that relates 3 of the trigs together.
All right. And then can we do 6?
Yeah. So the part that's maybe, what the heck do I do with that, is that cotangent is undefined. So remember, if something's undefined, it basically means its denominator is 0, right?
Yep.
So cotangent is tangent is the reciprocal of cotangent. And I know if I have 0 over something, that's just 0, right? So cotangent being undefined just tells me that tangent is 0. Cool with that?
Yeah.
Okay. If secant is 1, its reciprocal, cosine, is also going to have to be 1, right? Is that okay?
Yep.
If I use the Pythagorean identity 1, I know that sine squared plus cosine squared is equal to 1. That's P1. Sine squared plus cosine squared equals 1.
Yep.
Yep. So subtract 1 from both sides, square root both sides. Since I'm square rooting 0, I don't need a plus or minus. Sine is just 0. Is that okay?
Yep.
And then the reciprocal of sine is cosecant. If I have something over 0, that's undefined. So I think that's all of them then, right?
So you're basically using the Pythagorean theorem for kind of all those questions, 3 through 6?
Yeah, probably it comes, one of the Pythagoreans is probably going to pop up in all of them. I don't,
Okay. So just like starting it off, you can use those to get like the basic one?
yeah. Well, anytime I'm told like something is positive or negative,
Okay.
I'm told that because I had to use one of the Pythagoreans, and then when I take the square root, I need to know whether to use the positive or negative.
Okay.
So that should be a good clue to you whenever you're told something is positive or negative in this situation, that you're going to be using one of the Pythagorean identities
Okay.
to kind of figure that out. Cool?
Can you do 14?
Yeah, no problem. You don't have to make faces about it. No, it's okay. You can make faces if you want. I'm just telling you, like, don't have to feel bad about asking questions. It's no big deal. That's what this time is for. If you already knew how to do it, you wouldn't need me. You know, if you don't know how to do it, you can certainly ask about it. All right, anyways, here. Typically, the first thing we like to do is look for something algebraic to do. I have two fractions that are being added together. If I want to do that, what do I have to have? Common denominator. Do they have a common denominator right now? No, they're clearly different, right? One is, I have one minus sign and the other is one plus sign. Great. Okay? So if I wanted to make a common denominator, what would that common denominator have to be? Is there any factor in common between those two? Well, one isn't a factor because it's being added or subtracted, right?
Yes, the sign.
So the sign's not a factor because, again, they're being added or subtracted, right? Factor is multiplicative. So like example, Alyssa, for vocab's sake, right? Like 2 and 4 have a factor in common because they're both divisible by 2. 3 and 5 have no factors in common because nothing divides both of them other than 1. Is that okay? So here, is this more like 2 and 4 or is it like 3 and 5? Okay, this is like 3 and 5. These are relatively prime, right? Like is there anything that I can divide by both of them that I can do the division? Nothing, right? Like the only thing you could conceivably use would be sign, but you can't, one divided by sign doesn't reduce, right? So there's no common factor. So what that tells me is that my least common denominator is just going to be 1 minus sign times 1 plus sign. So, and again, like worst case scenario, if you're not sure what the least common denominator is, if you just multiply the two denominators together, that's going to be a common denominator. You might have some reducing to do after you do that, but like it's a common denominator, it'll work. It just might get a little bit messier than it has to, but it's still fine. You know what I mean, Alyssa?
Yep.
Okay. So if I multiply the numerators, 1 times 1 plus sine y, it's just 1 plus sine y. And then if I multiply the other ones together, I have 1 times 1 minus sine y, so I just have 1 minus sine y. And then I have my common denominator. All okay there?
Yep.
So a lot of algebraic things I see I can do now, right? In the numerator, I see that I have a plus sign and a minus sign. Those can add to give me 0. I have a 1 and a plus 1, so those can add together to give me 2. And the denominator looks like something that I would want to FOIL out. Now, in some cases, I like to leave the denominator factored. This is not one of those cases. Why would I know that I wouldn't want to leave this denominator factored? There's nothing left in my numerator to reduce it with, right? The numerator just has a 1 in it. There's no trig stuff in there. So, like, there's going to be no reducing that I can really do. I'm not going to just leave it factored. Like, I'm going to multiply that out and see if there's an identity I could use on it afterwards. Does that make sense?
Yep.
Okay. So here I notice that I have like a plus b times a minus b. Right? I have like a difference of 2 squares situation. So I'm going to use that multiplication shortcut to just write this as 1 minus sine squared y. If you didn't notice that and you FOILed it out, you'd end up at the same thing and just take an extra step. Cool so far?
Yeah.
Okay. So now, no more algebraic things to do at this point, right? So I'm going to look for an identity. Where on my identities sheet should I be looking? I would look at the Pythagoreans. Here's how I know that. It's because I have addition and subtraction, and I have something squared. Those are the only identities that include adding things together. If I have addition or subtraction, they're the only identities that are really in play for me. If I'm going to look at the whole thing. You know what I mean, Alyssa? So if I go and I look at my identities, the one that I'm going to use is the P1, because I know that 1 is equal to sine squared minus cosine squared. Or I'm sorry, 1 is equal to sine squared plus cosine squared. Yizers. And I like that because I had already a minus sign squared in the denominator, so I can combine those together to get 0. So that leaves me with just 2 over cosine squared. Typically, when I get to this kind of a stage, I'm going to think about this as 2 separate fractions. I'm just going to think about this as 2 times 1 over cosine squared. It's not necessary to do that step, but I'm going to do that now for us so I can point out to you how I know which identity to look for, because that feels like, especially early on, that's the thing that we're really concerned with, right? It's like, how do I know which identity to use next?
Yeah.
This is how I know. I have a fraction with a 1 on top. Should scream reciprocal identity, right? That's the only way to get rid of a fraction, is really one of these reciprocal identities, or maybe the quotient identity, but clearly there's a 1 in the numerator, so it should scream reciprocal. If I go and I look at that, I know that 1 over cosine is secant, so 1 over cosine squared is secant squared, and I still have that 2 hanging out front, and that is as good as we can do. Grace.
So, like, how do you know when to stop? Because, like, if you go like this way, like, we go that way.
Yeah, sure.
Like, I would have stopped at 2 over 1 minus sine squared.
Okay. So the question would be, to me, is I have 2 terms in the denominator, right? Is it possible for me to get that to 1 term? Because that would be simpler. So I'd have to check that.
Okay.
And if you tried, you should be able to find that, like, oh yeah, I can do something that gets me down to 1 thing down there instead of 2, right? And then here, I know to keep going because I can ask myself, is there a way to get this to be not a fraction instead of a fraction? Because that's simpler than, a not fraction is simpler than fraction, right? Just like 1 thing is simpler than 2 things. So that would be what I would say to you if you're looking for, like, hey, how do I know when I'm done? That's the question to ask. Like, okay, I have 2 things here. Can I make it into 1 thing? And sometimes you might not be able to. And that's okay. But in this case, we could. And in general, here I would tell you that on the homework quiz that you'll get where you do this, there'll be things that go down to 1 thing. So I'm not going to give you, like, something that's tremendously tricky. At least in terms of, like, knowing whether you're done or not. The in-between might be tricky. But the end, knowing that you're done should not be. That's what I don't want it to be, right? Like, the steps can be tricky, but, like, knowing whether you finished or not is, like, a terrible question.
Like, would you consider this tricky to know if you're done or not?
I would say no, but I know what you're feeling. I understand why you're saying was tricky. Because I look at it and I immediately, like, okay, there's 2 things there instead of I can make that 1 thing. Right? Like, but that's a fair question, right? And, like, being able to talk a little bit more about, like, what am I seeing that tells me to keep going is an important question, right? You have no intuition as to that, right now. Doing some problems and hearing me talk through it and what I'm thinking or what I'm seeing, those are important questions to ask. So, like, at any point while we're doing this stuff, if you're like, hold on, why did you do that again? Or, like, how did you know to do that? Like, those are important questions. And if they come up and I'm not saying it, like, stop me and ask. Alyssa, I saw your hand up.
Yeah, can you just please, like, go on down how you went from 1 minus sin squared to the sin squared y plus the cos?
Yeah. Yeah. So what I did is, because I had 1s and I had addition or subtraction and I had something squared, that to me was an indication that one of the Pythagoreans would work. So the Pythagorean I used was P1 that says that sine squared plus cosine squared is equal to 1. So I took the 1 and replaced it with sine squared plus cosine squared.
How can you just do that?
Because they're equal, right? Those 2 things are equal. That's what P1 says. Sine squared plus cosine squared is equal to 1. I had a 1 right here, and I replaced it with sine squared plus cosine squared. Does that feel okay? Sure. The other way to think about this, Alyssa, is that you could rearrange this equation. If I looked at P1 here, if I subtract sine squared from both sides, you could think about it that way and say, okay, 1 minus sine squared should be cosine squared. And you could use that. That would be okay as well.
That makes sense.
Sure, you can think about it that way. It's doing the same thing. Sure. Taylor?
For number 25,
Yes.
why is it 4 pi over 3 and not 5 pi over 3? Because I know that, like...
Okay, hold on a second. I just need to look at my unit circle real quick. So this is plus or minus root 3 is what tangent is.
Yeah.
So that should be like 2 pi over 3 and 4 pi over 3 and 5 pi over 3 and pi over 3. Is that what you're saying?
Well, because when I think about it, it's like, are both of them negative at the same time, or can one of them be negative and one of them not be negative?
So you're going to
Like,
get,
square root.
so you're going to have, yeah, you're going to have tangent x equals plus or minus root 3. So you'll break that into two equations, right?
Oh, I just put it over 1.
So if it's positive, you're going to get pi over 3 and then 4 pi over 3. If it's negative, you would have got 2 pi over 3 and 5 pi over 3.
So do we use all of them?
Mm-hmm. Yeah.
Do you use all of them?
Yes.
Because on the answer key,
Uh-oh.
it only gives you pi over 3 and 4 pi over 3.
25. Oh, dear.
So I only had down pi over 3 and 5 pi over 3.
Mm-hmm.
So I was like,
Yeah.
so we use all.
So those, all 4 of those are answers for part A.
So then does that change for B, since it's like every point on the unit circle, would it just be pi over 3 like plus like half of pi?
Yes, it would be plus pi over 2. Mm-hmm. You are correct. Yeek.
This is kind of a problem.
Taylor? I agree. All right. Should we talk about 5.3 here, the last section?
How many sections are in this chapter?
3.
3?
3.
There's 5 questions.
Yes,
So
Grace.
will our tests be like after break, or will we not have tests on this chapter?
Oh, we're gonna do a test on this chapter. It'll probably be the end of the week we get back or the start of the next week.
Okay, so we'll have like time.
My plan is when we get back, we're just gonna have days in class to work on stuff.
Okay. Thanks.
Take a day or two to do that, and then we'll see where we're at. And because a lot of this stuff that we're doing is stuff that just like takes a little bit of time, takes some reps. If we need 3 days when we get back to do stuff and ask questions and work on things, like it's not the end of the world. My suspicion is that chapter 6 will probably be an exam only. Like we'll peer on the exam only. We might not have time to squeeze in the chapter 6 test in between the time we get back and getting ready for the exam. We'll see where things are at, but I'm one that hates the idea of like, we have the mini exam week before the actual exam week where everybody gives you a test the week before exams, which is like kind of terrible. I personally agree. I don't feel any need to do that.
That's good.
So if that's the way things land, if it's 2 weeks out, then
Still not give it to us.
I would at 2 weeks out. But I'm just being honest,
Yeah,
right? Like at some point, like you could make the same argument and keep going farther back and farther back. Be like, we don't have to have any tests ever. It's like, well, okay, you just, like, do we just want to have an exam, like, and just everything is the exam? Okay, we could do that. I mean, it's less for me to grade, but that's an awful lot of pressure. Okay, so the last section is about proving identities. So I know the P word in there sounds pretty scary, but you guys can do this. So here are my rules that I have for you guys when proving these identities. So to prove one of these identities, you must start on one side and end with the other. Should probably say with. What you're not allowed to do is work a little on the left side and work a little on the right side and meet somewhere in the middle. That's not okay. It's got to be all on one side or all on the other. Let's see. So typically you'd want to start with the more complicated side. That typically makes life easier. If you're not sure which side to start with the more complicated side. That's not a hard rule, but that's typically good advice. Number 3, when in doubt, convert everything to sines and cosines. When you need to combine fractions, make sure you're using a common denominator. Rule 5, the difference of two squares is your friend. Rule 6, eye on the prize. Always keep the other side in mind that you're trying to get to. If you're not sure which identity to choose one that's going to get you closer to where you're trying to get to. Again, the only one that's like the hard rule is the first one. All the rest of these are basically advice. You know what I mean? Okay. Let's do some examples. So here we'll ask you to prove the identity, and we'll do a couple of examples. So let's say we have the identity tan x plus cotangent x is equal to secant times cosecant. First step is we want to choose a side to work on. My advice is typically to choose the more complicated side. Which one of these two it seems like the more complicated side? The addition side or the multiplication side? The addition side. 2 terms is more complicated than 1 term. Everybody's okay with that? So let's work on the left side. Not a requirement, but it's typically easier to go from more complicated to less complicated. Going the opposite direction can be very tricky at times. So far, so good? Okay. So looking at the left-hand side, keeping in mind that we're trying to get to the right-hand side, any ideas of where to start? Write things in terms of sine and cosine. Seems like a good plan to me. That's what I would do. So using Q1, I can rewrite tangent as sine over cosine. And looking at Q2, I can rewrite cotangent as cosine over sine. Now, while I'm doing these problems, I'm always going to work vertically down my page. I would encourage you to do the same thing. So far, so good? What to do next? We have 2 fractions that we're adding together now. We need a common denominator. In this case, what would that common denominator be? Sine x times cosine x, right? Just the product of the 2 denominators. So we multiply the first fraction together by sine x over sine x, and the second one by cosine x over cosine x. Should we write that? Might as well. These are notes if you want to go back and look at them. Probably helps to have that step written in there. You okay to hear? What next? Yeah, look at the numerator. Sine squared plus cosine squared. That seems like the only reasonable thing to do. Now, I've written this as 1 over sine x times cosine x. That's probably not the most convenient way of thinking about this, though, right? Keep in mind, where are we trying to get to? Yeah, so probably it would be easier to think about this as 1 over sine x times 1 over cosine x, right? I don't need to make that a separate step. I'm just going to adjust my thinking. Is everybody okay with that? And now, when I have 1 over something, what kind of identity should that be screaming at us? The reciprocals. So 1 over sine is cosecant, and 1 over cosine is secant. And obviously it's multiplication, so I can change the order so that it matches. We're all done. What you guys think on that one?
So like that's your final answer, like,
So my answer is the work. Remember, it's a proof.
okay,
So like all of this stuff needs to be there for my answer. So again, think about it as explaining to your teacher why these two things are equal, and your work is how you do that explanation. But this should be helpful for you, Grace, because it tells you exactly where to stop.
right,
You stop when you get that,
yeah,
which is nice, right? Here the stop sign is posted for you.
okay,
Does that,
yeah, that's good.
okay. You say you don't ignore stop signs anyways?
No, when there's like cop,
Oh, okay. Then you run them.
like when there's like this cop, I don't
Oh, when there's a policeman, you don't run them. Otherwise, you do. Okay, that makes sense.
I feel like that's really
Yeah, totally relatable. Stop signs are always optional, right? As long as you're okay with going to jail and killing people and stuff.
Only if that? Only if there's a cop.
Yeah.
No. See, I told you it was in my.
Okay, let's look at the next example here. Anybody with an idea here? Which side would you want to work on?
I don't think it really matters, but
I don't think it really matters either. I would say they're both a single fraction. Okay, enough about our traffic exploits. I would say, yeah, I think the left-hand side seems fine. And it doesn't really matter on this one either. It's going to be kind of the same. Okay, so presume we start on the left-hand side. What would you want to do first? I'll give you a hint. Rule 5. What does Rule 5 say?
the difference is square.
The difference of two squares is your friend.
So square the, multiply by 1 minus sign.
You mean 1 plus?
Yeah, that's what I meant. No, it's not square. Oh, it's the 1.
So when I do that, I get in the numerator, I'm just going to write this as cosine x times 1 plus sine x. Why didn't I bother to multiply those together?
Because that would be,
Well, look at I on the prize. I have to have a 1 plus sine x in my numerator. I have it right there the way I've written it. That's why I'm not going to distribute it, the cosine through and just write it as like in that factored form, because I know that something's got to reduce here at some point. So, you know what I mean? It's not the end of the world if you had distributed it through, but it just means you're going to have to factor it again later. Not the end of the world, but I'm not into doing extra work. Zach. Nope, Luke.
Does the 1 then become sine squared plus cosine squared?
Yeah, so we could do the same thing in the denominator. Take that 1 and replace it with sine squared plus cosine squared. Or Alyssa, you could think about the whole thing as just cosine squared. Either step is fine. Everybody okay with that? Then what? we'll just reduce. And that gets us to the other side, and we're finished. Now, where was the tricky step there? Was really the very first step, right? Once you decided to do that, everything from there was relatively obvious. Another hint going back to the, if we go back to the very first step in justifying how I knew to do that. If I look at the numerator here, 1 plus sine x, I don't have any obvious way I can turn a cosine into 1 plus sine x, right? Everybody agree with that? So I'm just going to put it there by multiplying the top and bottom by 1 plus sine x. Right? I don't know how I'm going to get rid of the 1 plus sine x in the denominator quite yet, but I know I got to get it in the numerator somehow. I can do it just by, brute forcing putting it in there, and then dealing with whatever the consequences of everything else later, which is, again, another way to kind of, to give you an idea of like how you would think to do that. The fact that then you see the 1 minus sine x in the bottom should be like, oh, for sure that's what I want to do because now I have a difference of 2 squares. That's a great idea. John?
So why can we not, work the left side to a certain point and then take the right side to the same point? Wouldn't that prove it as well?
So it's not as rigorous in terms of a proof. Like if you can do what you're saying, then you can do it all on one side, right?
I see. But if going from the other direction helps you solve it, then what's the point of rewriting it the other direction?
That's the convention. That's how proofs are written. It's like we're proving this statement, so you start at one side, you show the other. And really, for an equality statement, you would then start on the other side and show that you can do both directions.
Yeah.
We're not going to actually make you do both directions,
Yeah.
but that's like, if you're actually trying to prove something, you should do it both forward and backward for an equality sense, which is kind of like yuck. Okay. Well, let's do another. I think I have 1 or 2 more here. Oh, 1 more. Oh, 2 more, I slide. This is, I think, a pretty easy one, though. Who said these are fun? I agree. This was my favorite part of trigonometry as a high school student. Massively my favorite. I felt like I learned more algebra doing this than any point in my algebra classes beforehand. Because if you screw an algebraic thing up on something like this, you can't do it. And it's like, oh, yeah, that's not how you can reduce fractions. Oh, yeah, that you do need to have a common denominator. Oh, yeah, those 2 things aren't like terms. It really reinforced all those algebraic concepts for me.
This might be a dumb question, but it will always be doable.
Mm-hmm. Mm-hmm. Unless your teacher made a mistake. But, okay, which side looks more complicated? Left. Okay, Chelsea?
That's a U, right?
Yeah, they're all U's. Great. Left side. What do you want to do first on the left side? Yeah, we'll FOIL that out, right? We got a difference of 2 squares. Let's multiply that out. Everybody good with that? We okay there? Who sees the end by now? 1 person, that's it? 2? One minus cosine squared. What can I do with that? It's a Pythagorean, so we can go straight to sine squared, or if you wanted to replace the 1 with sine squared plus cosine squared, you'll get to the same spot. And then the quotient, and we're done. This was a pretty easy one. That's not bad, right? Okay. Actually, I'm going to write this as a bracket. Probably makes it easier. Okay, which side do you want to work on here? Okay. I would have chosen the left, but the right is the obvious one based on the more complicated rule. I'll show you why, and I would have chosen the left-hand side after we do it the right-hand side. They're both doable. They're not really that much different. Okay. What do you want to do first here if we're working on the right-hand side? Well, keep a mind on where we're trying to get to. I wouldn't distribute because it's already a multiplication problem. The left-hand side is a multiplication problem. So I wouldn't distribute the cosine through because now it's just an addition subtraction problem. That's worse. Does that make sense? The I and the prize rule tells me that I want this to be multiplication the whole time. Well, I see something pretty obvious to do right away. Look inside the parenthesis, or the bracket, I should say. Take out a sine squared. And I know that I have to do that because I have a sine squared on the left-hand side, I and the prize, right? I know at some point there's going to be a sine squared that has to fall out of that. Everybody's okay with what we did there? Okay. Look inside the bracket again. That's really the thing that we have to work on. What does that look like in there? The word you should be saying and what it looks like starts with a Q. Looks like a quadratic, right? It's not exactly a quadratic because it's degree 4, but it's in the quadratic form. What is something that we can often do with quadratics? Factor. That's what I would be thinking to do here. So you want something that multiplies to give us 1 and adds to give us -2. What are those two numbers? -1 and -1. So I have sine A minus 1, sine squared A minus 1 and sine squared A minus 1. Why is it sine squared A minus 1 instead of just sine A minus 1? Because it's a degree 4. Yeah. Everybody's cool with how we factored that? Okay. Now what? This is agonizingly close to something good, isn't it? Well, it's not exactly, right? So if we remember the Pythagorean, if I subtract sine squared from both sides, I have 1 minus sine squared. Here we have sine squared minus 1. So it's close. Anybody with that idea? So simple, guys. What if I just factor a -1 out? Right? I can do that and then the signs switch and I have what I need. You guys agree with that? That's a good trick to remember. If the signs are wrong, maybe factoring a -1 out can fix it. So 1 minus sine squared, what's that? Cosine squared. Oops. And then when I multiply all that stuff together, the negatives cancel, right? Negative times negative. And I have cosine to the second, to the fourth, to the fifth. And that's what I needed. What was the worst part about this one? All that factoring, right? So this is why I would have used the right-hand side, because instead of factoring, I'll just have to FOIL, which is usually easier. So the first thing I would have observed was that I have this cosine x all by itself. So I would have thought about this as cosine to the fourth times cosine A. And then cosine to the fourth is basically cosine squared. And the reason I wrote it that way is because I know that all of this stuff has to turn into all that stuff with the signs. So I'm just going to rewrite cosine squared as 1 minus sine squared. I go ahead and I FOIL that piece out. And then distribute the sine squared through, and I'm done. Oops. Oh yeah. Squared. And that to me felt a little bit easier because all I had to do was FOIL there instead of having to factor. But either way was possible. Listen.
Just a quick question. On that third line, is that still sine to the second?
Oh, this one right there?
No, in the first one.
This
same line, but the first one.
Oh yeah, this is a squared.
Oh, thank you.
Yep. So again, either way, doing that would have been fine. Again, you'll notice that depending on how clever you are, sometimes it's easy to see what to do and sometimes it's not. Experience matters on this, like reps matter, trying things matters. Like unfortunately, there's not a magic elixir for these. It just kind of, you need to develop some intuition on what to do. The only way to develop intuition is to try to do stuff and have it work or not work, and get some advice here and there. But at some point, you just have to sit down and try a bunch of these until like it feels like you can put the puzzle together, because that's really kind of what you're doing, is just doing a puzzle. So eventually we'll do 47 through 62. That's not part of the homework set for this week. Remember, the homework set is just going to run through 30. Although that will be part of the homework set when we come back from break. So if you wanted to get started on any of those things early, not a bad idea. Everybody's okay with that plan?